Hello, geometry, and welcome to Unit 2. We are past Unit 1, which talks about the basics, the formulas, the angles, some of the concepts we are going to see vocabulary the rest of the year. And now we're into Unit 2, which is on parallel and perpendicular lines. And today we're going to start out with the basics. Okay, what are parallel lines? What are some of the concepts we are going to see here again in this unit throughout? So, starting out with the first question, what are parallel lines? First off, what stands out is I have lines in here. Okay, what I need to remember back from Unit 1 is lines. Okay, when we talked about lines back in Unit 1, remember these have arrows on both sides. So when we get into talking about parallel lines, all of our pictures are going to have arrows on both sides. So parallel lines, these are lines that never cross. Okay, if I am to draw parallel lines, these are going to be lines. They're going to stay the same distance apart. Okay, so notice how those lines this whole way, they stay the same distance apart. If I were to continue to draw them, they will never get closer. So now, how do you name parallel lines? So remember back in Unit 1, one of our ways of naming lines was to have these lowercase letters outside of them. I can name parallel lines simply by saying line N, line M, and the parallel symbol looks like an 11 or two lines that never cross. This is the parallel symbol. So now becomes the way, how do I know if I'm dealing with parallel lines? We talked a lot about that in Unit 1, like how do I know that I have a midpoint? How do I know that I have an angle bisector? So now comes the question, how do I know that I have parallel lines? Well, the first way is you're told in the problem that the lines are parallel. You see this. Another way that you know have parallel lines that shows up quite a bit is inside of the line, they will have an arrow. And that same arrow is going to be on the bottom line as well. So notice inside of line N and M, I have this arrow. They're both facing the same direction, and we have the same number. One arrow, one arrow. These lines would be parallel because they have the same number of arrows inside on the drawing. Okay, then we get in here to parallel planes. Okay, these are planes that never cross. Now, when we dealt with planes, we briefly talked about this, not too much. Planes were what looks like a piece of paper or looks like a box. Okay, so it's like I have these two boxes and they'd be on top of each other. A lot of times here, if I think about it, I take two sticky notes. Okay, one sticky note is a plane, another one is another plane. Okay, it's like right here, they're going to be facing the same direction and they continue to go up and they're never going to cross. They're never getting closer or further apart from one another. Okay, it's hard to draw them here on a piece of paper. Simply drawing something like this, they look like they're going the same direction, not getting closer. How do you name parallel planes? The same way that we talked about here. So planes are given with capital letters, which we didn't get into, and I'm not going to worry about this. So plane M parallel to plane N. Okay, all that I want you to do is to realize that planes are like a piece of paper. So if you have two pieces of paper facing the same direction, that's what makes them parallel. Okay, what we're really going to get into here is here at the bottom. Okay, transversal is going to be a big topic here today. So what is a transversal? A transversal is a line that crosses over two or more lines. So what is going to happen is we are going to have two random lines. If I have a line that crosses over both of them, so for example here at the bottom, I have these two random lines that are going side to side, but I have this line going kind of diagonal. It crosses over both of the lines going side to side. This line that crosses over both of them, that is known as a transversal. Okay, so a transversal is any line. It could be up and down. It could be side to side. As long as it crosses two lines, we can say it's a transversal. It crosses the bottom line at that green point that it is placed, and the second green point is where it crosses the other line. Okay, so let's go here. We're going to look at some examples here with the parallel lines and the transversals before we go any further. So looking here at these, we're going to look at the diagrams and determine, do I have parallel lines and do I have a transversal, yes or no? Okay, so looking here at the picture for A. First thing that stands out to me right here, I have those arrows. These arrows, remember, indicate that I have parallel lines. So line L is parallel to line K. Okay, remember 11 is the parallel symbol. They get it actually because of the double L in the word parallel. Okay, so L and K are parallel. So now I'm going to look and say, do I have a transversal? Is there a line in my picture that crosses over two others? And my answer is yes. This straight up and down line crosses over L and K. This becomes my transversal. And my transversal, if I name it, would be line, the letter up there is T. Line T is my transversal. L and K are my parallel lines. Okay, going down here to B. Okay, I do not have parallel lines simply because it's not told to me, nor do I see these arrows like I saw in A. So here in B, I have no parallel lines, but I do have a transversal. Notice this line, and it's line L, if I trace over it in purple, it crosses over both A and B. So this line L is a transversal. You do not have to have parallel lines to have a transversal. Transversal is line L. Okay, and when we do the script L, it sometimes looks like a little like fancy, or you can just write it line L and it looks like a straight line. Okay, going on here to C, the last one of this example. Do I have parallel lines? Yes, I actually have 3 parallel lines. My lines that go side to side, if I trace over them in pink, all are parallel because of these arrows. Sometimes your arrows are filled in to look like triangles. Sometimes they are not. So, really I have line, I can't name it by a line. There's no script. I have to name them AD, 2 points with a line symbol above, is parallel, what looks like 11, to BE, and include another parallel to CF. There are my parallel lines. All 3 of them are parallel. Transversal, do I have any line that crosses over 2 or more? Well, I have 2 transversals. I'm going to highlight them in blue. Okay, there are my 2 transversals. So my transversals, okay, we name a line with 2 points. If I look at this first blue line, there's D, E, and F on it in terms of points. You name 2. So let's say I say DE with a line symbol above. Same thing. If I cover up this, there's A, B, and C. You choose 2 points. Let's say I choose BC, put my line symbol above. Only 2 points to name a line. So 2 transversals, 3 parallel lines. Okay, that's going to help us when we get in here to some examples here later on. Okay, now that we looked here at some examples with parallel lines and transversals, what we're going to realize is that there are angles that are created from these lines and these transversals. So first off, getting into it, we have exterior angles with transversals. These are angles that are outside. Now, what it basically means is what my pictures are going to look like is we have two lines. Sometimes they'll be parallel lines, sometimes they will be not, but we will have one transversal. Okay, in between the two lines that's a transversal crossover, that is going to be my interior or my inside. Okay, outside of those angles is my outside or my exterior. What we're going to realize is that these interior and exterior angles, they create like a sandwich. The outside or the exterior is like the bread. Okay, the interior is the inside, the meat, whatever you're going to put in. What are interior angles? These are angles that are inside, and we've already seen that in the above picture. Okay, I'm not going to need to draw another example because I'd be copying the same thing. So now, what we realize is when we have this picture, okay, and I'm going to work on a sticky note so I can take away. When we have this picture of two lines in a transversal, we get that there are 8 little angles that are created, and based off of these, some of these have some special relationships or special names, and today we're going to talk about the names. The next class we'll get into relationships. So getting into some of the special names. Okay, one of the special names is corresponding angles. These are angles that sit on different lines. Okay, different non-transversal, be a little bit more fancy, transversal lines that are in the same spot. Okay, corresponding angles, you're going to hear me say this a lot. Same seat, different table. And we'll look at what that means here in a second. Okay, that's what you hear a lot of times when I say corresponding angles. Same seat, different table. So, what looks like it's going to happen is we are going to have my two lines. We're going to have my transversal. Okay, I have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to fill in the angles. Okay, my tables consist of where does that transversal and the line cross. So one of my tables is going to be angles 1, 2, 3, and 4. My other table is going to be down here at 5, 6, and 7, and 8. There are my two tables. Corresponding angles are if you would put the tables on top of each other, what angles are sitting on top. So angle 1 and angle 5 are on top of each other. Angle 3 and angle 7 would be on top of each other. Angle 2 and angle 6, angle 4, and angle 8. Those are my corresponding angles. Same seat. They're both sitting here on the top left-hand side, but they're at different tables. One's at pink, one's at orange. Okay, alternate interior angles. These are also called Z angles, and we'll see why here in a little bit later in the year and the unit. These are, first off, interior angles that are opposite and on different sides of the transversal. So if I draw my picture, 1, 2, 3, 4, 5, 6, 7, 8. Okay, first off, if I mark my interior and exterior, exterior is like the bread, interior is inside. So I'm going to choose an interior angle. I say angle 3. Okay, well, I'm going to look and say what is opposite and on the different side of the transversal. This up and down is my transversal. I'm going to put a T there. On the opposite side of transversal is 4 and 6. 6 is the one that is opposite from it. I like to say alternate interior and exterior look like they form an X. So angle 3 and angle 6. Okay, those are alternate exterior, as well as angle 4 and angle 5. Okay, and a little indication into why there's Z angles. If you trace, like above angle 3, go down and trace below 6. When you trace, it captures both pink inside and it looks like a Z. That's why we call them Z angles. Okay, alternate exterior angles are the same as alternate interior, except they're exterior angles. These are exterior angles that are opposite and on different sides of the transversal. Okay, so I'm going to draw the same picture that I've been seeing. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so it's the same type of concept. Now, they aren't Z angles, but it's the same type of concept with the X. Notice 3 and 6, 4 and 5 if I drew an X over it. So if I think about drawing the X, let's see if I see it with a color. Okay, I'm drawing my X over my picture. What connects with the X? Well, I realize this side of 1 connects down here with this side of 8. So 1 and 8, angle 1 and angle 8 have to be alternate exterior. Okay, if I connect another one, I get that the other one works with 2 and 7. So angle 2 and angle 7 have to be alternate exterior angles. Okay, let's look here at the last two. Okay, consecutive or same side interior angles. These are interior angles on same side of transversal. These are on top of each other. Okay, so if I draw my picture, I have my 2 lines. I have my transversal 1, 2, 3, 4, 5, 6, 7, 8. Inside the lines is interior, outside is exterior. So if I choose an interior angle, so let's say I choose this angle 5, I'm going to ask myself, what is on the same side of the transversal, or what is on top of it? Angle 5 and angle 1. Oh, not angle 1, angle 3, sorry. Those are my interior angles. They're on top of each other. Okay, then if I look and say angle 4, okay, angle 4 and angle 6 would be on top of each other. They are both inside. Okay, notice they don't cross over the transversal as well. On the right-hand side of the transversal is 4 and 6. Left-hand side is 3 and 5. Okay, the last one works with the same way as what we just talked about, consecutive same side exterior angles. Notice what I didn't really talk about here at front. Sometimes they're called consecutive exterior angles. Sometimes they're called same side. I'm getting you familiar with both wording. So these are exterior angles that are on the same side of transversal. Notice same side is in the definition. So, have my picture. 1, 2, 3, 4, 5, 6, 7, 8. Interior, exterior, exterior. Okay, 1. I look and I say 1 is on the left-hand side of the transversal, also on the left-hand side as 7. I have to mark my transversal with a T. Angle 1 and angle 7. Okay, then I look and I say on the right-hand side is 2 and 8. So angle 2 angle 8. Okay, those are all the special angles. Now what we're going to do is we're going to take some pictures and we're going to see, can we name the special relationships? And that's what our focus is here when we get into class as well. Given this picture, can we name the relationships? So a lot of times what it comes down to, it's like you want to circle the relationship, and then when you think about it and you go away, it's like you erase that relationship. Or sometimes what I like to do is have the same drawing for each problem. So when I go to a problem, sometimes I will redraw each one so that I can highlight and I can mark. Okay, so I have R, P, and Q. So first off, this is my diagram and I redrew it so I can work with it. R becomes my transversal, so I'm going to mark that T. Okay, in the first problem, they're talking about angle 1 and angle 3. So if I highlight angle 1 and angle 3, first off, in between P and Q is the interior, then we have the exterior. Okay, 3 is an interior angle, 1 is an exterior. Since they are not both interior or exterior angles, that takes away any of the relationship that talks about interior and exterior. That means this has to be a relationship that has one exterior, one interior. And I'm going to tell you, the only one to check if you have one of each is corresponding. So if I think about this, one table would be here in yellow. It would be 3, 4, 7, and 8. My other table in orange would be 1, 5, 2, and 6. If you put the yellow and the orange tables on top of each other, just simply moving them on top, 1 and 3 would be on top of each other, meaning these are corresponding. Okay, now, once you deal with that, sometimes you have to look and say, I need to redraw. I'm going to tell you this unit with lines, there's going to be a lot of redrawing that is going to take place. So, I have this picture. Okay, we're talking about 2 and 7. 2 and 7. I have them marked. Okay, I have my interior, my exterior. 2 and 7 are both interior. The only interior ones we have are the consecutive or same side interior and the alternate interior. Okay, these are not on the same side of the transversal. 2 is above, but 7 is below. So they are not same side interior. These are alternate interior because if I were to draw an X, they connect. Okay, now I'm going to abbreviate alt and also interior. Okay, now I have to deal with 5 and 8. Okay, so again, notice each time I'm redrawing my picture just so that I can mark and I can get a fresh picture each time. So 5 and 8. 5 and 8. Mark my transversal and my interior and my exterior. 5 and 8 are both exterior, and notice 5 and 8 are both below the transversal. Since they're on the same side of the transversal, these are consecutive, or you can call them same side, and I'm putting exterior because they are outside. Okay, now 6 and 7. I'm going to do 6 and 7 here in purple because we're going to talk about something. 6 and 7, notice they're on both the bottom of the transversal and they're both interior. These are the same thing as 5 and 8, except consecutive, same side, except these are interior angles, so I put INT to represent interior. Okay, big difference that you have to know whether your angles are inside or outside, so you know if the relationship is an interior or an exterior angle. So then I look and I say I have my transversal, my 2 lines, 1, 2, 5, 6, 3, 4, 7, and 8. Okay, I marked my angles. Now we want 5 and 4. 5 and 4. Oops. Okay. Interior, exterior. 5 and 4 are both exterior, and now they are not on the same side. 4 is above, 5 is below. If they're not on the same side, think about drawing an X. Do 5 and 4 connect? And the answer is yes, they connect with this one line. Since they connect with an X, this is alternate, and they are outside, so it's exterior. Okay, now the last two we're going to talk about here on the picture. So 5 and 2, 5 and 2. These should look familiar from last unit. 5 and 2, they are across from each other. These are vertical angles. Okay, vertical angles, I'm going to tell you also linear pairs are going to show up this unit as well. Last one is 7 and 4. Hopefully you're seeing 7 and 4 the same as 5 and 2. These are vertical angles. Okay, vertical angles and linear pairs will show up. Okay, now I'm going to look at a couple of this last one, which is just a little bit harder of a picture. Okay, we have multiple lines, multiple transversals. What ends up happening when you have a picture like this? This is a tic-tac-toe picture. If you have to name a relationship with a tic-tac-toe picture, you have to find what line do they have in common. The line they have in common becomes the transversal. So if I just look at a couple of these, because we'll talk about some of this in class. 1 and 12. Okay, just I'm going to circle here. Here's 1, here's 12. They have line A in common. My transversal is line A. And the two lines that A crosses over are C and D. You're going to cover up the line that your transversal does not cross over, which in this case is B. Now here is my simple problem. Okay, if I have to, here's my interior, here's my exterior. 1 and 12 are both exterior, and if I connect with an X, they connect. This makes 1 and 12 alternate exterior. Okay, 7 and 13. 7 and 13, they both sit on line B. That makes my transversal line B. So I'm going to put it as a T now. Say line B. B crosses over C and D. So I'm going to cover up A. Okay, even though this is backwards, here's my interior, here's my exterior. 7 and 13 are both interior, and they're both on the left-hand side of B. So these are consecutive or same side, however you want to call them. And these are interior because they are inside. Okay, 10 and 15. 10 and 15, they both touch D. D crosses over A and B. D does not cross over C, so I cover up C. 10 and 15, they are both inside, and if I connect with an X, they connect. So these are alternate interior. Notice how I just have to make my problem a little bit simpler. Oop, and I could put my transversal. My transversal was line D. 2 and 5. 2 and 5 both sit on line C. So my transversal is line C. C crosses over A and B. C does not cross over D, so I cover up D. Okay, 2 and 5 are both interior. They're both inside. And they're both above my transversal. So these are consecutive or same side interior. 6 and 16. 6 and 16, they both sit on line B. B crosses over C and D. It doesn't cross over A, so I cover up A. 6 and 16, they're both E, so they're both exterior, and they're both on the right-hand side of your transversal because my transversal was line B. So these are consecutive or same side exterior. Okay, 3 and 15. 3 and 15, they do not have any line in common. If they have no line in common, meaning no transversal, there is no relationship. There's only a relationship when there's a transversal. Okay, 11 and 10. Oh, 11 and 10, I shouldn't have to do anything. These are right across from each other. These are vertical angles. Okay, 4 and 13. 4 and 13. They don't sit on a same line together, so there's no transversal, no relationship. Okay, now, 3 and 4. 3 and 4. Ooh, these are side by side. Notice if I do the cover up, 3 and 4. I cover up everything. They sit on a straight line. Angles that are side by side that sit on a straight line. Here is an example of your linear pair. Okay, 7 and 14. 7 and 14. They both sit on this line B. That means my transversal is line B. B crosses over C and D, so I cover up A. 7 and 14. 7 is interior, 14 is interior. They are not on top of each other. They are diagonal from each other. That means that these are alternates and they are diagonal. And since they're interior, alternate interior. 12 and 15. 12 and 15. These are both circled down here. They sit on line D. So my transversal is line D. D crosses over A and B. It doesn't cross over C. 12 and 15, they're both interior and they're both below the transversal. Since they're on the same side of the transversal, these are consecutive or same side. And since they are interior, they are interior. 1 and 11. Okay, 1 and 11 both sit on line A here. So my transversal is line A. Cover up. So I'm going to say 1 is exterior and so is 11. They sit on the left-hand side of A since they're on the same side of the transversal. These are consecutive, same side, but these are exterior because they are outside. Okay, we will talk more about if the picture gets a little bit difficult with what we call these tic-tac-toe problems. Okay, get ready in class. We're going to be practicing. I'm going to give you a whole bunch of examples where you're going to have to know the relationship. Okay, that's what our focus is going to be on class. If you have any questions, ask them so I can make sure to put them in the presentation. If not, I will see you in class. Have a great day.